Welcome back, class. We're moving on to parallelograms and trapezoids, and I hope you're doing well. I hope you're enjoying this class. I hope you're feeling successful. A couple of quick reminders. Best practices for math is to take very careful notes, physically to write things down. So you'll want to freeze the screen. You want to copy down what's on the screen and then press play and listen to what I say, take some more notes, and that way you're kind of doubly, triply absorbing what I'm information I'm giving you. Okay. So parallelograms and trapezoids. Just as a reminder, a parallelogram has sides that are parallel to each other, and that's why they call them parallelograms. And I've always tried to be really clear, and I really suggest you follow this. You see this word formula here on the far upper left here. I just like to write it out, just reminding myself, okay, that's the formula. I'm going to plug into that formula to solve, especially for the rest of the quarter, because we're going to be using lots of formulas. And don't stress, every time you do it for homework, you'll have them in front of you. You'll have access to your notes. Additionally, even on your tests, you'll have the same thing. So, um, all right. So the formula for a parallelogram's perimeter. Okay. And remember, the perimeter of something is the distance around something, just like I'm drawing a distance around this word perimeter. Okay. And so the formula is we've got 2 times S1 plus 2 times S2. Okay. Which is S1 stands for side one. Okay. And so, if that's starting to sound like Greek to you, I'll draw a little arrow. Let's just say that this is side one and this is side two. Okay. So basically, you would have side one, and then, 2 times is you're basically calculating this side here, and then 2 times side two means you're calculating this side right here. Okay. As well. And so that's why it's 2 times S1 plus 2 times S2. Or another way to do it would just be to add up all the sides. And and remember, if these are parallel, they're going to be equal to each other. Okay, these two opposite sides. So, all right, that's so the and then there's a formula for the perimeter. Again, I'm going to circle my word formula here. Okay, well, here's my magical formula. I'm going to follow that very carefully for the perimeter of a trapezoid. Here's my trapezoid on the right. And so P perimeter is S1 plus S2 plus S3 plus S4. Okay. Technically, those are really the same two formulas, because if you just added all the sides, you would get the perimeter. So for either parameters or parallelograms or for the trapezoids, it's kind of the same thing. Okay. All right, let's move to the next slide. And what I have here is a couple of sample questions. Okay, so I want you to freeze the screen, copy these down, and we'll take a look. All right, example question 1. What's the perimeter? Perimeter, again, distance around of a parallelogram to the right. Okay, we've got one that's this parallelogram over here on the right. It's got a 4-foot side and a 7-foot side. Opposite sides of each other. So the opposite sides here of these parallelograms are the same. Okay. So I just rewrote the formula up at the top, just kind of modeling what I'd really like you to do, start doing in your homework and on your quizzes. Just rewrite the formula. P perimeter is 2 times side 1 plus 2 times side 2. So I started plugging in my numbers. P equals 2 times, okay, here's side 1 here. We'll call this side 1 here. Okay. 2 times 4 plus 2 times side 2, and we'll call this side 2 here at the bottom here. So that is P is 8 plus 14, which is 22. Okay. And that is, as if you're going to fully write it out, it's actually, since we said it's 7 feet here and 4 feet. Okay. It's technically 22 square feet, because area of it, I'm sorry. No, it isn't square foot, is it? Okay. We're just talking about the perimeter. So there's a good example of making sure we're clear of what we're talking about. It would not be square feet. It would just be feet. Okay. All right. Just to be clear on that. All right. Let's take a look at the next one. Example question. What's the perimeter of the trapezoid to the right? Okay. And this is a trapezoid. It's got two parallel sides, but then it's got other sides that are not parallel. And it gives all the dimension and the formula. Again, here it is. I wrote it out. It's just P equals, add up all the sides. Okay. So we added them all up 5, 3, 5, and 8. And we got 21. That should not say square feet. That should just say feet. Okay. So just to be clear on that, that would be feet, not square feet, because we're talking perimeter, not area here. Okay. All right. Next slide. Oh, actually, what I want you to do now is I want you to complete the page 101, all the odd questions in the book. So stop the video, do those homework problems. That way you're really absorbing this concept of following a formula to find a perimeter, which is the distance around, so it's not square feet. Okay. And I will get the next slide going here. Okay. All right, you can copy this down. Not a whole lot on the screen, but we're talking about the formula again for the area. Okay, so now we're talking about the area, which is kind of what I was accidentally mentioning on the previous slide. So the area of a parallelogram, it has, here's my formula here, A area equals B times H, where B over here is B for the base of it, okay? And H is the height of it, all right? But I want you to notice carefully, I'm going to draw an arrow to the height here. It's this little dotted line. That's actually the height. It's not this distance here, okay? Because that would be actually technically longer, but it's the base times the height. And you might recall this is very similar to triangles, where the formula for the area of a triangle is 1/2 the base times the height, and the height would be the distance from the top to the bottom. Okay, not necessarily of a side. All right, so that's it. Just a very simple formula. Base times height is the area of a parallelogram. Okay, here's an example question. What's the area of a parallelogram to the right? Okay, we've got a base down here of 13 inches and a height, notice with the dotted line, of 7 inches. Again, I rewrote my formula, just really getting in the habit of making sure I'm following all the steps. Because remember, in math, slower is faster. Slower is more accurate. Slower leaves you less confused. A equals base times height. A equals 13 times 7. A equals 91. In this case, now it is square inches. I'm writing that out. And so, because we're talking about surface area. Okay. All right. Let me move on. Now, here's a formula for the area of a trapezoid. Okay, so I'll let you freeze the screen, copy what you see on the screen, and then come back. All right, so in this case, our formula here, our magic formula here is area is, now this looks pretty kind of fancy here, 1/2. Okay, this reminds us of triangles, doesn't it? 1/2 times, and remember when it's parentheses right next to something, that means times in math, okay? 1/2 times B1, okay, plus B2. All right, now what does that be? B1 stands for base number 1, so that's going to be up here, okay? That's the base. We'll just call that base 1, and this is B2. Basically, our two bases are that the parallelogram sits on, okay? So the top and the bottom, yeah, think of it as that. So times the height. Notice that H right there. Okay, I'm going to circle it here. This is the height. It's not another side, but it's actually the height. So I'm going to unplug my pen because it seems to be I'd call it the wandering pen, where it just starts doing its own thing here. Okay. So we've got an example question at the bottom of the screen. What's the area of the trapezoid to the right? Okay, and so we've got a base 1, B1 of 6, and a B2 of 9, and a height of 5. I have rewritten the formula at the bottom left of our screen here. Area is 1/2 the B1 plus the B2 times the height. Now I'm just going to plug in those numbers. Area equals 1/2 times B1 is 6. You'll see that this is my B1, my 6, okay, plus B2, which is 9, times 5, which is the height, okay. And so, and by the way, if you might recall, they had this thing called PEMDAS way back when you were maybe taking math before, which is the order of operations. P stands for parentheses, E stands for exponents, and then multiply, divide, add, and subtract. Well, do the stuff inside the P, the parentheses first. Okay, so we're going to take, we've got our numbers here. I'm on the third step here, 1/2 times 6 plus 9. So I'm going to add 6 plus 9 and get 15. Okay. And then I can just punch that into my calculator. 0.5 times 15, get an answer, take that answer and times 5. And that will give me 75. And then times 1/2 is 37 and 1/2. And again, we're talking about area here. So now we are talking about square feet here. Okay. All right. I want you to stop the video, complete problems 1 through 5 on page 109 of your textbook, and then we will continue. All right. I'm going to let you pause the video now and take down some notes. We're going to talk about circles. All right. Circles. And that's kind of fun. It's kind of interesting in real life. I've had to do this before. Bought for my kids a swimming pool. It was one of those ones you blow up, you know, and then put in the backyard in the summer. And so I've got the swimming pool that's got a certain length across. And when you start figuring out how much chlorine to put into it to keep it from algae growing and things, it'll say on the bottle, put this much in per this many square feet of water. So then you start having to figure out, okay, how much area of area of water do I have? And so you're going to start using formulas like this. People who put in wood flooring, sometimes when they're working on circular areas, they might have to do this kind of math to figure this out as well. But anyway, circles. I'm going to talk about a couple of little things on the screen here. Okay. Let's slow down and make this really clear. Okay. All right. The first thing underneath the words, purple word circles, is the word radius. Okay. And that is the distance to the middle of a circle. Or another way to phrase it is the distance halfway across a circle. Okay. And you might know that a circle doesn't matter where you start. I could start here at the bottom of my circle. I could start over here. If I go to the middle, it'll still be the radius. It'll be the same as the one that I've drawn here at the top with the line here that's halfway across. Okay. So that's called the radius. All right. The diameter, the second term down, is the distance all the way across a circle. And so I've got my little arrow here, which I'll circle here on the screen here. This is pointing to the radius here that goes all the way across my green circle. All right. And then you've got a third term. So you radius halfway, diameter all the way across, and then circumference is the distance around the circle. Okay. So in a sense, that's another word for perimeter. Okay. But now, because it's a circle, we call it the circumference, distance around the circle. And there's a formula for that, which I'm going to circle here at the bottom to find the circumference, the way distance around. Okay. It's C, standing for circumference, equals pi times diameter. Now, some of you are going, what kind of pi are we talking about here? Well, this is a symbol, and the ancient Greeks came up with this, and the symbol for pi was, as I've said here at the bottom here, pi. That's how to spell it. Pi is it. That symbol means 3.14, and then it goes on forever. They actually have pi contests at once a year where people try to memorize the most digits of pi because it keeps going on forever. And so, but for our purposes, 3.14 or 22 over 7, 22 sevenths, because 27 goes into 22 3 times, and then there's a remainder, which would be the same as 0.14. All right, so that symbol, whenever you see that symbol, you might want to start that pi symbol. You might want to start thinking, oh, just 3.14. That's what that is on my calculator, which is probably the easiest way to do this. Okay, let's take a look at a sample question. Find the circumference of the circle that has a diameter of 14 inches. Okay, now I'm gonna model good practice for. I'm gonna circle the word diameter. So it says it has a diameter of 14 inches. That's the distance all the way across. Okay, and over here to the right, at the bottom of our screen, I've written out the formula again. Formula: C circumference equals pi times diameter. That's my magic formula. Okay. And then I go down one step. C circumference equals, I just put in the number 3.14 times 14. And again, parentheses means times when they're side by side. And then C equals 44 inches. And this is in length. This would be the length distance around the circumference around the circle. Okay. So those are the steps for finding the circumference. All right, let's move on. And let's talk about another sample question, okay? Find the circumference of a circle that has a diameter of 9 feet. Rewrote the formula, C equals pi times diameter. Plugged in my numbers, C for circumference equals 3.14 times 9.1, okay? And this 9.1 came from the problem, the question itself, okay? Punch that into your calculator and you'll get 28.574 feet. Okay. And I just wanted to, let's see, oh, did I mess something up here? No. Oh yeah, I did want to point something out here. I have a little note here I added just because you're going to see this in a few of your problems. Note the diameter is twice the radius. Okay. Now, I want you to write that down, and here's why. Because you're going to have a couple of questions that are going to look like this red circle, where they're going to ask you, find the circumference, the distance around of a circle that has then they'll say the radius, okay, the radius here, okay, of 5, for instance, US, pen, work. So if they ask you for the radius, you got to pause for a second. Wait a minute, that's not the diameter, that's the radius. Radius is half the way distance across. So if if it's halfway is 5, then all the way is 10, right? So whatever that radius is, multiply it by 2, double it essentially, and you will have your diameter. And I just wanted to note that because you'll probably run into a couple of questions like that where the math text will give you the radius. Pay close attention. The radius is only half, and the formula calls for pi times the diameter. Okay. All right. I want you to complete problems 1 through 11, the odds only of your textbook on page 111. And let's check and see if I have anything else for you this session. All right. What else do I have? Yes, I do. One more slide here. All right. So I want you to pause the video and I want you to take some notes, copy this down. All right. All right. Last slide for this session. Okay. Now we're talking about the area of a circle. Okay. The area of the circle. We just got through talking about the distance around the circle. And that's what we've patterned in all of these shapes. First, we talked about the perimeter, distance around, what the formula was, did a couple of problems. Then we moved to the area of that shape, whether it was a trapezoid, parallelogram, and now a circle. Okay. All right. So the formula, here's our magic formula. The area of a circle is pi times the r now. Look at that r here. That's the r squared. Okay. So rewritten right below here is where I'm pointing my arrow. Area equals 3.14, which is easier to do on a calculator, times r, because r squared means times itself. Okay, so like 2 squared is 2 times 2. So let's look at this example question. What's the area of the circle that has a radius of 7 inches? Okay, rewrote the formula. Area of a circle is pi times r squared. Okay, Start plugging in your numbers. Area equals 3.14 times, well, it says the radius is 7, and that is halfway across, and that's part of the formula. 7 times 7. Plug those numbers in your calculator, and you'll get 154 square, and it's in inches, so square inches. Okay. Next problem. What's the area of a circle that has a radius of 2.1 feet? Okay. Again, here's my formula. The area equals pi times r squared. Start plugging in my numbers. Step 2, 3.14 times 2.1 times 2.1. That's the r squared. And the r squared came from, it gave us the radius, right, in the story problem here. Okay. So that's where that came from. Plug all that in. I get 13.84 square feet. Okay. Now you can have more homework than normal this time, because we're going to get into some more story problems, and we're going to get into kind of applying all of your skills so far for area and perimeter of a bunch of these shapes. Okay. So the first thing I want you to do is complete the odd questions on page 112 and 113, working with circles. Okay. Then what I want you to do is read carefully, just as review, on page 114 of your text. It's a review of the formulas. They're all right there in a box. Okay. For perimeter and for area, and it gives all these shapes. Okay. So just look it through and go, okay, that's right. That's that formula. That's that formula. And again, you don't have to memorize them. You're just visually and mentally reviewing them. And then I want you to do these story problems and questions on random shapes, all kinds of these shapes that we have. So we won't be just working with circles. We'll be going back to different shapes. Okay. Do only the odds on page 115 through 117. And if you have any questions, please be sure to ask, and I will be thrilled to answer, but be really specific in what your question is, so I'll know exactly how to answer.